Hello, PascoMath grade 7 teachers. Today we're going to look at the standard MAFS 7.EE.1.1. We're going to unpack that standard a little bit, look at what the teacher should be doing in the classroom as well as what the student should be doing, show mastery of the standard, as well as maybe anticipate some misconceptions our students have and how we can address those. So let's go ahead and get started. So 7.EE.1.1 is apply properties of operations as strategies to add, subtract, factor, and expand linear expressions with rational coefficients. So it's pretty straightforward. Unpacking it, they need to apply previous learned properties of operations as strategies to add, subtract, factor, and expand linear expressions. So again, that coherence piece, and so they know a lot of these properties already from prior grades with working with whole numbers, and now we are going to use it on linear expressions. Those properties include distributive, commutative, associative, identity, inverse properties of addition, multiplication, as well as zero product properties of multiplication. Coefficients are limited to rational numbers. Those are integers or positive, negative, fractions, and decimals. And we need to use properties to write equivalent expressions. So some things you can do as a teacher. Present sets of expressions and ask which are equivalent, allowing students that time to reason and use the properties. For example, we can say like Maria thinks two expressions, 2 times the quantity, 3a minus 2 plus 4a, and 10a minus 2 are equivalent. Is she correct? Explain your reasoning. Here I can see two sides. A lot of students might think they are equivalent. Then you have the group that thinks they aren't. They have to justify why, and you can use that student work as a leverage for learning in your classroom. Provide students with opportunities to explain their reasoning and writing about how they're creating an equivalent expression using precise math vocabulary. That's a great opportunity for math practice 3 and 6. And so that 6 with that precise math vocabulary and that 3 with their constructing the viable argument. So again, just have them write their equivalent expressions. Use substitution as a method to determine if two expressions are equivalent. And so if they think they're equivalent, have a value, plug it in, see what you get, and it should be equal if they're equivalent. Use equivalent expressions for real-world problems. So if you're looking at what the student should be doing, they need to reason to identify sets of equivalent expressions. They should discover that there are more than one expression, or that there is more than one expression equivalent to a given expression. So you can just write one expression on the board and see how many different expressions students could generate, like in 5 minutes, and share out. Just be a quick activator to show how many different expressions could be equivalent to the expression written on the board. Change an expression into an equivalent expression using properties of operations and combining like terms. Students need to be able to represent real-world problems with equivalent expressions using properties of operations, again, combining like terms and substitution, and solve them. Communicate orally and in writing using precise math vocabulary on how equivalent expression is created, and defend why two expressions are or are not equivalent. Again, that math practice 3, construct viable arguments and critique the reasoning of others. A great opportunity there. So some misconceptions we can anticipate. Sometimes when the work of an expression requires several steps, students get caught up on simpler things like the order of operations. And so this example here, 7 plus 2 times the quantity 3x minus 5 plus 2x, they might want to add the 7 and the 2 first, or only distribute that 2 to the first term and not that second term. And so to address that misconception when they're forgetting to follow the order of operations with expressions is have them substitute that value in to the original expression and then their final expression, the simplified one, to see if they get the same value. When they don't, have them discover their error and remind them that they need to follow the order of operations there. And so that would be a great error analysis task where plug in the value of 2. What do you get in the original expression? Now what do you get in the final expression? And once they realize they're different, but yet there should be equivalent expressions, it just puts it on them to figure out their own error, which is really cool. So thanks for watching. If you have any questions, feel free to contact me or your regional specialist, and thank you for making PascoMath more awesome.